Hey all, I'm going to go over a complex equation with you, which is just to combine the equation in an electrical circuit. So this is that series parallel equation. I've done it a couple times in class, but I figured I'd do it one more time and just let's go over it as a group in this video. All right, so let's give it a shot. All right, so you have this equation on the board and it looks a little complex. So what we have is we have the first resistor, R1, and then that comes off to R2, R3, and then we have R4, R5, R6, R7, and then ground. So what we want to do again is we want to find the total resistance of this circuit. So to do that, the first thing that we need to do is we need to start trying to combine anything we can that is in series. So I cannot combine anything in series with R1 because I have a break here in a parallel equation. So let's leave that alone for right now. Let's move downstream a little bit. R2 and R3 are in series. So I can put parenthesis around this and I can combine those. That's going to become a new single resistor. I use the series circuit formula. So remember the series circuit formula for RT equals R1 plus R2 plus R3, etc. You just keep going, adding them up, right? So I can combine these two. So I can turn this into, I'm just going to call it RA and make it one resistor. And I'm just going to draw it up there so you understand that. Down here again, I have, these are in parallel, but I have R4 and R5 come off of here, and they are in series. So I can combine those, and I'm going to put parenthesis around those, and I'm going to make that RB. So that becomes its own simple combine. So I've combined these two. So now I've taken these two combined, these two combine them. So let's redraw that, and let's see if we can redraw it. All right, so what we have now is we have the first resistor, which we had to leave alone. We've combined the two, which was R2 and R3 from over here, and I've redrawn it to be RA. I've also combined R4 and R5 that are in series to become RB. So now we have a new equation. It looks a little different than that, right? I've simplified it some. So let's look and see what we've got left. All right, now I still have a parallel circuit here. So I can't do anything with this because it branches off and this is in parallel. So what I need to do is I need to simplify this further. I have two resistors that are in parallel, R6 and R7. So the rule for that to find the total resistance again is that crazy formula, which is 1 over R1 plus 1 over R2 plus 1 over R3, etc. Just keep putting them out there, right? So I'm going to take that formula and I'm going to take these two resistors and I'm going to plug them in, 1 over R1 plus 1 over R4, or 1 over R6, 1 over R7, and that is going to give me the total resistance of this value. That then becomes a new single resistor value, which we can call RC. Now we have a series circuit. This is going to be in series with this, okay? So this is going to become one resistor. So I could combine these, which is then going to become a new single series circuit. It would be a single resistor in series. I could combine those. That becomes a new single resistor. And then I have a parallel circuit, and I can do my parallel equation again from up here, and that becomes a single resistor, and then I simply add that to R1, and that gives me the total resistance of the circuit. So if I redraw it, I can redraw it one more time. All right, so let's just review this again. So I can combine these two to make that RC. So I redrawn it up here, so I've got R1. I have the combined R2, R3 here. I combined R4 and R5 to be RB. So there's RA, there's RB. Now I can combine these two in a parallel equation, I can turn that into a single resistor, which is RC. So here's my new equation. I have R1 in series with RA, RB, and RC. I can simply combine RB and RC because it's in series. So let's do that right in front of you. We're going to combine that into a single resistor, and that we're going to call, let's say, RD. So now what do we have? We have a series parallel equation. I simply put this into my parallel equation, okay? Again, series is different than parallel. So for a parallel equation, again, is 1 over, and we're going to say RA and RD, 1 over RA plus 1 over RD. We're going to solve for that, and that's going to give us a new single resistor value, and then we're going to have a simple R1 plus R, and let's call this RF when we figure this out. So this becomes RF. And that now is a just a really simple series circuit. We combine those two, and that gives us total resistance of the circuit. So we figured that out. Now, let's go back to the very beginning. We have this big, long, crazy equation, but we know the total resistance of the circuit. Okay? And we're going to use that. Let's say we combined all this, we came up, and let's say RG is the total resistance of the circuit. So we're going to take that and we're going to plug that into Ohm's law so I can figure out the total amperage that flows through R1. That's the big thing that I need to know. So the total resistance, I need to know what is the amperage of the circuit. So I want to know what the amperage flows through this circuit is. So I know the resistance is RG down there. So it's RG. Just use Ohm's law, E over I times R. So the voltage is 12, right? I times R. What do we know? We know the total resistance, RG. RG divided by 12 is going to give me the total current that flows in through R1. Then that branches out. It's going to be different because I've got all this going on here, but at the very end, the same amperage will be going through here to ground. So I'll have an amperage combined here and an amperage combined here to give me the total amperage flow here. And I have the same amperage flowing through R1, and then it branches off and I get different values. So my next equation is I need to find out how many volts is used up in R1. Easy. I know two things. I know the total current. So the total current flowing into R1, and I know the resistance of R1. Let's use 2 for the resistance. Let's throw a number out here. 5 amps, who cares? I know that 5 amps flows in and out of R1, and I know this is 2 ohms. So all I do is plug in. I want to find the voltage drop through this. So I'm going to use Ohm's law again. I want to know what V is. I don't know what the voltage in that equation is. Let me clean this up a little bit. That was awful. So I want to know what is V. That's the voltage drop through here. So I know the amperage, 5. I know the resistance of R1, 2. 5 times 2 is 10. That means that R1 loses 10 volts. That means how many volts is left over? 2 volts is left over. Now I can put 2 volts into this equation, okay? So I can come all the way back over here, right? And I know from this last equation here, when I got to this point, that I can start saying, well, there's only 2 volts left over here. So I can start to apply that here, okay? And I can start to figure out what the total amperage is that is flowing through RA, and then I can plug that into the equation here, all right? So all I want you really to do is just to learn from this video how to combine and simplify to get to an equation to get to the total resistance of the circuit through that. So then you can take that number and you can plug it in Ohm's law to figure out the total circuit current, the total amperage that flows through the circuit. apply that to Ohm's law again and multiply it by the resistance to figure out the voltage drop, so then you can keep going downstream. All right, I hope that helps. Just to walk through it again and just keep plugging away. You guys are doing great, and I'll see you tomorrow for the test. See ya.